participants. So let's move on to the first keynote speaker, Dr. Bas Kemp. Dr. Bas Kemp is professor and shareholder at the Adaptation Physiology Group of Wageningen University. The aim of his research group is to facilitate and support adaptation of domestic animals to their changing and challenging environment in order to optimize the animal welfare and health. Bas Kemp is involved in many national and international research projects and published more than 360 peer-reviewed papers. Bas is going to take us along in the Healthy Livestock project, and the title of his presentation is 4 Strategies to Reduce the Use of Antimicrobials on Farms, the Healthy Livestock Approach. Bas, welcome in the studio. I hope you had a nice trip from Wageningen. Can you tell us, how is Wageningen doing at this moment in the COVID times?
It's quiet in Wageningen because you're not allowed to go to the university at the moment. But it's always a very nice city. So yeah. We hope that after the COVID period, things will restore.
And a lot of online education, Bas?
At the moment, yes. Okay. Education is online. Only practicals are given physical, but then you take, of course, precautions in terms of hygiene. Let's hope,
especially for the students, that they can dwell out and go to campus again.
For sure.
That's a great experience. But Bas, go ahead and take us along in your presentation.
Thank you very much, Han. What I will do is, in this presentation, well, first of all, I will rename my name. I'm Bas Kemp. I'm a professor of adaptation physiology in Wageningen. Han just described to you what it actually is, this work that we do. And very simple, what we do is try to optimize the environment in such a way that animals are happy, healthy, and productive. But I'm also a member of the core team of a project, an EU project, and this project is called Healthy Livestock. And what I will do in this presentation is take you along the 4 strategies that we use to try to reduce the use of antimicrobials on farms. And that is actually the main thing I'm going to talk about at this moment. And as already mentioned by the previous speaker, it's a joint program between China and between Europe. And indeed, we mutual benefit from the other approaches, the other ways that we work. But I must say that in both Europe and in China, top research is done to try to get further on these 4 strategies. It's not only a matter of cooperation between institutes and between universities, but it's much broader. There are also non-governmental and governmental organizations involved. There are also industry is highly involved, as you can see in this slide. It's actually that a lot of different parties are involved in that in this. So it's really a multi-actor, multi-group approach that we follow with this Horizon 2020 EU program. And as I said, it's partly financed by the European Commission, and it's partly financed, the Chinese part is financed by the Ministry of Agriculture of China. The main objective of the Healthy Livestock project is actually to reduce the use of antimicrobials applied to the pig and broiler industry in China and Europe, and of course also to prevent subsequent residues of ending up in the food chain and the environment. And we do that actually by 2 approaches, and the one is that we improve on-farm health and welfare, and we like to do that without compromising productivity. And I can tell you that the examples we have been studying till now actually show that if you are able to of course, improve health and welfare, this is also not compromising productivity. Actually, you gain in terms of productivity. So it's a very healthy approach in the Healthy Livestock program. As I already mentioned, there are 4 strategies. They're depicted here. The first one is biosecurity, the second one is resilience, the third one is early detection, and the 4th one is precision medication. So the first one, biosecurity, is all about trying to prevent a bug to come into the farm. So to prevent pathogens to come into the farm, and if they enter the farm, try to keep them confined within one compartment within the farm. So you're really trying to keep the bug out. That's actually your approach in biosecurity. All the other strategies accept that there could be bugs or pathogens coming into your farm, and how do you deal with that? And the first strategy there is resilience. So this is the second strategy of the program. And resilience is actually meant is targeting at the resilience of animals within the farm. So, for instance, as we all know, we all got a COVID vaccination. At least a lot of us got a COVID vaccination. And what you can see is that some people get sick, seriously sick after that, and some don't bother at all. And that's actually what we approach, that's the way we approach resilience. So we approach resilience in a way that we say animals are able to withstand the challenge, withstand the disease challenge, with minimal loss of function. So there's hardly any loss of function, also in terms of performance data like growth, feed conversion, etc., or mortality. So a resilient animal, and what factors determine resilience of an animal, is the second approach that we use in this Healthy Livestock program. The third strategy is early detection. And in early detection, the strategy is try to get the bug as early as possible. Try to diagnose it. Actually, what I should say is try to identify that there is a pathogen on your farm even before you see the clinical symptoms. Thank you, Ham. And of course, that's quite another approach. It also asks for individual approaches. So look at individuals that are already infected, so that at a very early stage of spread of a disease, you can already prevent the further spreading of that disease by taking measures based on your early detection program. And the last example is precision medication. And precision medication is all about trying to give the right amount of the right amount of antibiotics to the right animal at the right time. So, and that's especially relevant when you use group medication. So, for instance, via drinking water, you can imagine yourself that even individual variation in drinking water intake can already give a lot of variation in the amount of antibiotics that is actually put into the animal. But I'll come back to that later. So these are roughly the 4 strategies, and what I will do now is for each strategy, I will go a little bit more in depth and explain you some examples of that strategy. So the first one is biosecurity. And as I already said, the general approach in the biosecurity program is to reduce the risks of introducing pathogens, exposure and spread within a farm of pathogens. And the approach we take here is that we actually make tailor-made herd biosecurity protocols and health plans. So it means that for each farm, it's studied what is the problem, what is the issue here, and also what are preventive measures you could take to keep this pathogen out of the farm. And this is individually tailored for a health plan and followed by health plans. So there are actually 2 biosecurity risk analysis tools developed in this program from the EU, and one is for broilers and one is for pigs. And the idea is that we use these to, what we did in amongst others literature reviews, is to assess the disease risks related to housing and management. So which housing and management factors are giving a risk for entering a disease in the farm, and what are preventive measures to cope with that risk. Secondly, actually what we did was define farmer tailor-made health plans. So what you ask yourself is, this is a farm, it has a certain setup. For instance, it's in the middle of nowhere, then you need other biosecurity plans than one which is a crowded in a crowded area in terms of pigs, farms in a certain area. So it makes differences for the farm what you do or what you not do. Based on that, a health plan is made. So this is an approach for this farm to increase its biosecurity, and it's indeed adapted to the farm-specific needs. And after that, in this program, we follow and monitor the risk mitigation by means of biomarkers. And actually what you can see, this is an example of the approach that we take. What we do is before and after we have implemented these health plans, we are going to follow the farms, and we're going to do that in a 12-month study. And what we do is, for instance, look at changes in health and welfare and productivity. So are the health plans effective in improving health, welfare and productivity? The second thing is if these biosecurity practices and health risk management, if it will hold. So is it also in the longer period, on the long run, possible to keep these health risks and the biosecurity plans in place? Or is the farmer saying, okay, I'm not going to follow it, or it doesn't break, it doesn't help? The other thing we follow is antibiotic usage. We follow some farm economic figures before and after implementation of the health plans. And we ask also the farmer and the veterinarians, who together have developed and discussed these health plans, their opinion about the health and welfare plans. So are you liking them? And now once you're implementing them, what are the benefits and what are the doubts? And also what we do is antibiotic residue detection on these farms in meat, drinking water and manure. Actually, this has been adopted in different countries in Europe, like Greece, Cyprus, the Netherlands, Italy and France. So in each of these countries, a group of about 20 farms is selected in which we have implemented these plans. And we're now looking what's coming out of it. Also, China did the same thing. They also have a number of farms in which they use these biosecurity plans to test how well it all goes. So, health plans is actually our approach in the biosecurity approach, to try to optimize and to keep the bug out. That's to keep the pathogen out of the farm. The second strategy we use is the resilience strategy, and this is the resilience of animals we're talking about. So here the resilience is actually defined as the ability to withstand or deal with pathogenic challenges. And that means that if we look at the performances also not only in terms of behavior or in terms of disease outings, but also in the performance parameters like growth and feed conversion and things like that. So what this program does within this strategy is to study the ways to improve the ability of animals to withstand or deal with pathogenic challenges. And we use two approaches. And one is, if you improve welfare of animals, can you actually reduce stress and thereby improve the resistance of animals against pathogens? And the other thing we used in this approach is using nutritional measurements, and these are from China, traditional Chinese medicines, but also probiotics, which are given to animals to see if you give these products, are these animals more resilient once they encounter a pathogen. So all these strategies we test in groups of animals that we eventually challenge to see if the strategy is working or not, making animals less diseased. Just one example of resilience through welfare improvement that reduces stress. This is an example of animals kept in an enriched environment. What you can see in this panel here is that animals are kept in a big group, and the ground is provided with straw, with branches of trees and with peat. It's a bit an enrichment of the environment, and we know from a behavioral point of view that pigs really like this environment. They appreciate it, they can play with each other, and they have a lot of fun. So in principle, they are happy in such an environment, as has been shown in different ethological studies. The other contrast to this enriched environment is a barren environment in which the animals have hardly any enrichment at all. There's just a chain hanging here that they could play a little bit with, but that's it. And what we did is we tested these animals in the different growth, in these different phases. They were kept in these enriched or poor environments from birth onwards till after weaning. And at day 14 after weaning, we gave them a challenge with porcine reproductive respiratory syndrome. And after that, 8 days later, it was followed by Actinobacillus pleuropneumoniae infection. So it's a combination of a virus and a bacteria, and this is a typical model for multifactorial lung problems. This is an example of what you can see in these lungs of these animals, and what you can see is these typical lung lesions that can occur if the animal is diseased by this model. The interesting thing is that we found a big contrast between the animals that were kept barren, enriched, in the percentage of animals that actually developed these lung lesions in their lungs. And in the barren situation, it was no less than 57%, and in the enriched value, it was only 7.1%. This is just one experience I show you here. We have been repeated these experiments and we find similar results. So the impact of this enriched environment on the resilience against disease, in this way mentioned as or quantified as the animals with lung lesions, you can see that there is a big impact. We also looked at the viral clearance of the PRRS virus. You can measure that in the blood, and you can see how quickly it clears. And day 0 here is the moment that we enter actually the bug into the animal. Then you see, of course, in both groups, you see a rise in the amount of PRRSV particles in the blood. And after that, it goes down again. And what you can see again is that in the enriched group, actually the percentage of particles in the blood goes down much quicker as compared to the barren. So another indication that these animals are actually more resilient to their disease. This was just an example on welfare improvement and the effects on the resilience of animals. The other approach was actually to follow, to improve the gut microbiota, or by traditional Chinese medicines, or by probiotics. And this is just one example of a Chinese study that was done. And in this case, it was animals were kept, these were broilers, they were kept continuously fed on probiotics and traditional Chinese medicines. And in this case, it was a component of astragalus. And astragalus is this little plant over here. And the animals were, again, challenged with E. coli, in this case, 14 days after the start of their grower period. And what you could see is that the combination of these probiotics and the traditional Chinese medicines actually resulted in reduced intestinal lesions caused by E. coli. You found better protective intestinal villi structure and also reduced inflammation. So also the approach, so 2 approaches to improve resilience, and they both seem to be effective in improving resilience of animals once the bug is on the farm. The third approach is actually the early detection approach. And as I said already, the importance of an early detection is important. And the way we do that is actually look at different precision livestock farming techniques that have been recently developed and to bring them into tools for early detection. And both generic health problems like loss of growth or loss of performance, not eating, but also specific health problems. Precision livestock farming is developing very fast. The idea is that you get an early detection of individual animals, you follow them in time, and you see when they deviate in pattern from the normal pattern that you normally see in that animal. I'll give you a few examples of that, just to give you a flavor of it. The first example is automatic assessment of feeding and drinking behavior. This has been developed in France. There are many other countries that are also developing these kinds of techniques, but this is perhaps a nice example. What you actually do in pigs is in this case is to follow the animals, and you start to measure individual feed behavior, so you know when they're feeding. There's also a way of assessing the animal's individual weight and drinking behavior. So drinking behavior, feed and water intake can be measured, and weighing can be measured. So in this case, the variation that you see in water and food intake and food and water behavior is used as a marker of saying, okay, something is going wrong. If the animals don't eat anymore, suddenly, then you have an effect. And you can see this in an individual animal by this technique. The other one is a more general system on measuring general activity. Normally, activity patterns go down if animals are sick because they are less active, and they are mainly because you can see some sickness behavior in these animals, which is quiet and more restful. And that's just a Doppler instrument in here. And you also can use individual accelerometers in the ears of individual animals that show movement again of these animals. So this is an approach in which you try to find individual behaviors measured in time and see whether they change in time due to a disease or whatever. Sometimes it's difficult to assess it in individual animals, so there's also some work in the program in which they use in Borealis elevated platforms. The idea about these elevated platforms, which you can see here in this table, is that they actually improve or they give possibilities of animals to rest. But it's also possible to supply these weighing platforms with electronic sensors, and that's single pad load cells, which are here, and you can then measure the weight of these elevated platforms continuously. And the idea in this project, although it has not been shown yet, it's underway, but is that you can combine that with medical medical treatments, and to see if there is a correlation between both. Another very nice example is that we are really making big progress in general in the precision livestock environment in using videos to follow animals. And this is a nice example in which they don't only measure the animal itself, so you are able to detect the animal. There are also possibilities to follow that individual animal once it's moving. And a nice trick about this one is that you can also detect the front and the rear of the animal. So you know what's the head and you know what's the tail. And you can imagine yourself, if you see a lot of head to tail behavior and a lot of activity of animals, this may be an indicator for the development of tail biting. And tail biting actually sneaks into a farm or into a pen at very low levels with little gentle bites and suddenly develops. So it's very interesting to see if with this precision livestock farming method, with advanced video analysis, you can make steps in terms of better detection of these kind of vices that happen on the farm. The last example I would like to say something about is precision medication. The idea about precision medication is to optimize and adapt the dosage of regimen, so not give too much, but also don't give too low levels. During metaphylaxis, which means in group treatments delivered by drinking water. This is work that has been done in France, and also some allied countries. We also did some work in this. And what you try to do is to assess the individual water consumption of individual animals. And you can do that by tagging the animals. And well, actually, the example supplied in the precision livestock farm, where you measure individual water intakes, is used here to measure these water intakes. And what you can see is that there is a typical diurnal pattern in water intake. In the morning, they start to drink, and in the evening, before they go to sleep, they also drink. But there is a huge variation. And that huge variation means that actually if you take such an individual profile and compare it to another profile, it would mean that the amount of antibiotics which you have in the water is more or less the same. But if you give that relative in the numbers of liters of water, of milliliters of water that an animal drinks, of course there is a large variation. And what they do is they combine this information, and they also measure the concentrations of individual antibiotic concentrations for individual animals in the blood. And by feeding a model, a pharmacokinetic model, population model, with this data on individual water intake variation and this data on individual antibiotic treatments, it's possible to predict individual antibiotic concentrations that are actually reaching the animal. And that is a way to work on dose optimization for veterinary antibiotics in the context of harmonization of this work. That's what's going on in terms of of the precision medication. So what I did is actually with you now run through all these three approaches: biosecurity, resilience, rapid detection, and precision medication. We are in full-time in the validation phase at this moment, and of course we also present new results in all kinds of things like policy briefs, technical notes for farmers. We try to influence welfare standards in this way, and we try to develop mobile apps. And of course, as a researcher, I should say, we always try to make publications also and presentations at conferences like this. Well, thank you very much for listening to me. It's a great pleasure. What I should say is that in June we have a meeting. Han will say some more about this, but in that meeting from Horizontal 20, together with the Schippers Group, we are going to get a large group of animals, a large group of humans in this case, together, also from China and from Europe, and to work further on these programs, and you will get a lot more information. And it's going to be a Science Meets Society Day. Han, thank you very much.
Yep.
I'll leave the word to you.
Well, thank you, Bas. Well, again, we have a few minutes for questions from the audience. I have a question, Bas. If I look at the program, I see that it focuses on pigs and broilers.
Yes.
And I can understand that. If I look worldwide, pigs and broilers basically are very important in meat production in many countries. But those strategies, do they also give results that are applicable for other livestock species?
Yeah.
And do you do something with that within the Healthy Livestock project?
Yeah, within the Healthy Livestock project, we really focused on broilers and meat producing. So actually, meat producing animals, I would say that was the primary target. But of course, if you look at the principles that you follow here, like biosecurity, etc., all the 4 strategies can be adopted for animals too. We don't concentrate on that in this program because we want to focus on a few species. It's already a very broad area that you target on. But indeed, the possibilities of applying these strategies in other situations for other types of animals is very relevant too. Yeah.
Well, I do not have right now questions from the audience, but you will join us later on in the forum discussion, Bas. So we have ample opportunity to address questions then. You did refer to the June meeting.
Yeah.
I think it's the 22nd till the 24th. Eh? It's a multiple-day meeting.
Yeah, but the industry day is a one-day meeting.
That's the 23rd, I guess. Eh?
Yeah,
I think I'm right.
That's the only thing I wrote down here, and it's the 23rd, indeed.
The 23rd meeting. It is in Bologna, and I can tell a lot about it, but I think it's far better, and we arranged that the hosts of that meeting, the organizers of that meeting on the 23rd of June, the Industry Day, that they will explain to you, give you a little preview of what to expect. So we'll start a video, and all participants can watch and, in fact, listen to the hosts, the organizers of that Bologna meeting. Go ahead.